let's get started. Let's boot the device first of all. And while we do this, I have some questions for all of you. How many of you are experienced in mobile app security? Of course you do. Okay, but not so many. That's good. How many have heard about the OWASP MAS project, Mobile Application Security, MASVS? Very good. I hope you still learn something today. How many use it regularly? A little better, okay. Nice. How many has contributed to the mobile application security project?
It's like already, you know?
It's in GitHub, yeah, Pancake has. Okay, so let's change that. Loading, and let's go. So this is me, Carlos Olguera. I have here let's click on the two apps and come from OWASP. I lead the mobile application security project as OWASP, at OWASP, and also work at NowSecure, so yet another NowSecurian for the list. And you can find me in LinkedIn and as Carlos Olguera, and in Twitter, X, whatever, at grepharder. So let's get started. We're going to chat about, this is a bit of a mobile hacking 101. Let's start with the attack surface of an app, because if you want to protect your app, you need to know how to hack it first. And to do that in an organized way, if you don't have any idea, it is good to have some guidelines. So that's what we do in the OWASP project, is provide you guidelines and things that you can use and try to make this accessible for everyone. So the project is not only for beginners, but it's also for professionals. So this is a guide that when you're a professional, you will want to come back to it and follow all the steps and all the guidelines that we have in there. So for this, we have a very special app this day that we are going to download to our device, which is r2talk. It's a possibly secure app. And and yeah, you can go, don't mind the German there, you can download it and get it to your device, and then you can extract it. Anything that I say in these slides, you can find in the MASTG. How to get an app that you shouldn't be able to get, how to install it, how to decompile it, all these things. So I'm skipping the explanations because then you can find it later there. So we're able to get the binary of the app. In this case, it's Android, so that's an APK. You just rename it to zip, unzip, and then you got the contents. There are many things inside. This is also explained in the guide. Android manifest, pictures, the code itself, and so on. So in here, just with this package, we can start looking at areas of interest. So let's see. There is an API key there. That should be bad, probably. One thing, the colors. You'll see the colors. They're all the same. They have a meaning. You will see that later. And they mean there is a category. So whenever you see the same color, the same tone is the same category. That will come later with some labels. So the next thing that we see is that after analyzing according to the guide, etc., we found a CVE on that second library over there. And also we can see that the app has obfuscation. All these things, apart from the CVE and the hardcoded API keys, they're not necessarily good or bad things. There are things that we are seeing in the app, and they they maybe have a meaning that you can use to hack it, or to know that it's secure as expected. So let's now run the app. So, boom, it cannot run. There is it detects root apparently, and I'm using a rooted device. So what do we do when we see this and detect root? They have an app and detect root. What do we do?
Cry.
Let's frida it away. Boom. Okay, now we can continue. So let's see what is in here. A login page, you can use biometrics, etc. So there are more stuff that we can analyze here. It uses OAuth for authentication, a new category, authentication. It uses TLS version 1.3, that's good, and talks to the R2Talk backend in the cloud. We see it also offers user authentication with biometrics. And now we open the app. So I don't know if you can read the conversation. It's very interesting. Hey girl, you going to the r2con? Not sure yet. You'll have to convince me. I heard Pancake's going to be there. And the rest, you know, radar. So we see chat messages. They should be stored somewhere, right? The app encrypts the messages. That's good. Another question is how it encrypts those messages. It might be poorly done. So you see there, it encrypts or stores in external storage. That doesn't sound very good. What else? You can send pictures of pancakes and cats. So these are also saved in external storage. This one is probably fine, but maybe other pictures more compromising, you know, that's maybe not a good idea. And it also allows you to share these pictures with other apps. So for instance, your own cloud, whatever, boom, then it's going to be there. So that's another potential attack vector we could use if it's not properly done. So you see a lot of X's there. We have many instances of all these different categories there. But there's many more to this, like there's thousands, hundreds of different weaknesses that we can find in mobile apps. But we can all put all of them in these buckets. So if you look at what I'm going to present, all the weaknesses, and you find something that is not on those buckets, let me know, I'll give you a prize. Because those buckets were specifically designed to contain all possible weaknesses. So what are, oh, I forgot, it uses the camera, also privacy, very important. Probably the mic and other things, right? So that shouldn't be a vulnerability, but a weakness is not necessarily a vulnerability. It can be something else that is bad because of GDPR regulation, right? So those colors, this is what I mean. So this is the attack surface of the app. You can attack the storage. You can abuse the crypto, maybe. Authentication, network, the interaction with the platform being the Android system or the iOS system. Then code quality, like, you know, buffer overflows and other stuff. Resilience against reverse engineering and tampering, Radare, Frida, etc. And privacy. Privacy is the latest one that we added, I think last year, not this year, because it's very important and it wasn't covered before. So this is a standard. It's called the MASVS. This is the highest level of everything. It presents these categories and some very simple controls, like storage. You should store the app data securely. Crypto, following security best practices, like crypto best practices and so on. So the requirements that it presents are very simple and very high level, but they get refined later in what you see here, the MASWE, which is the weaknesses enumeration. If you know CWE, which probably many of you don't, this is it follows the same concept, so to say, describing weaknesses at a higher level, but not as high as the MASVS. So this gets a bit more specific. And then we have the MASTG. The MASTG is explaining all those things that I told you before, like how to unzip the app and get into it and find all these things. And there are many techniques and there are many tools that you can use. And it has, of course, many test cases. So you have kind of like a checklist of things that, you know, if you do those things, you're going to find a lot of vulnerabilities or weaknesses and things that represent some kind of risk in the mobile app. So this is to illustrate that a little bit. So we go from the highest level, very abstract and very general. It's not even about Android or iOS specifically. Something like insecure crypto is bad, to the weaknesses, which speaks to one specific thing, like weak crypto algorithms are bad, and the app uses those. And then we get to the MASTG, the testing guide, where you get to the hacking. You get your hands dirty and you go and test for these things. Specifically, you will search for cipher objects in Android that use the weak DES algorithms, for instance. So this is another view of the same thing. So you can see that there is even more. We start with a control from the MASVS. It's about using current strong cryptography and industry best practices, very abstract in general, but that's intentional. And then we have a specific weakness related to best practices in cryptography, which is about random numbers generators that should be cryptographically secure, right? And then for that topic, we have many tests. One being searching for insecure random APIs, like this can be the random API in Java, for instance, but also looking for non-random sources, like developers sometimes think you can just or you can just use the time from the machine as a random or some weird stuff. So we're going to look for that as well. And the cool thing, you will see, I'm very excited about this thing later, is the demos. And not demos in sense of conference and presentation demo, but we have actual demos with sample code and the test scripts. So this is like, we're going to take those tests, we're going to apply to a real app, so you can learn how this works. And do it yourself as well, you will see. So this is everything in our website, masowasp.org, and it's also in GitHub. So we have the MASTG repo, MASVS repos, everything is in GitHub, and you can contribute, and it's really nice. This is the website that gets built out of all these repos and documents. And here you can see the weaknesses. The weaknesses are the newest one. They're still in development, so the MASVS is there for many, many years, but the weaknesses are very new. And they are like a refined version of those controls, as I explained before. If you go to the website, you see the full list of the current weaknesses with IDs, titles, the platform they belong to, the MASVS IDs, profiles. That's what you see there as L1, L2 is like maybe you have an app that doesn't care about jailbreak or root detection and these advanced threats, so you would just apply L1, is very basic security protection, or if you have like a banking app, financial, you will use L2. If you have a gaming app, you would use a resilience profile as well. So this is like you are tweaking according to the threat model of your app, and then you will select the weaknesses that you need to test for. This is the page of a weakness. It's very small. I know it's not intended for reading, but it explains what is bad in an overview, what can happen if the app has this weakness, what is the impact, how can this happen? Like, how can a developer introduce this weakness into a mobile app? How to fix it, of course. And it has the links to tests. So you can navigate from weakness to test, to demos, and so on, as you will see. If you navigate to a test, the test is going to explain first why we are testing for this, like specifically for one example, because, why we are testing for this, because the weakness is general. It applies both Android and iOS. It explains important concepts. But here in the test, this is a test for Android or for iOS. It's going to talk about the specific APIs that you need to select, the specific features that exist in iOS and Android. So this is much more specific, and then it gives you steps that you can follow, 1, 2, 3, and then you will get an output. That's called the observation. And then in the end, explains how to evaluate and get an answer. Is the app vulnerable to this or not? And then it has some links to demos. And the demos are going to be, okay, let's get this test. Let's get an app and run the test on an app. And that's the demo. We're going to explain everything in detail, why this app specifically has this weakness. So for building all these demos, we needed some apps that are, let's say, reliable and simple enough also. And the idea was to contain that weakness in an app that has nothing else but that weakness. For learning purposes, this is great, because if you want to reverse engineer, you won't be distracted by other things going on in the package, in the binary. And also, I think it helps you if in some situations you need to test for something very specific on a very specific Android version. For instance, testing things like on iOS, ATS configurations, on Android, the network security configurations, clear text enabled or not, and this version, if you have this parameter, if you have this min SDK, whatever, so it can be very complex. If you have an example like this that you can just take and play with it, as you will see now, that is so much better. So I created these two apps, one for Android, one for iOS. Intentionally, like the UI is, I try my best to make it look exactly the same. And it's very simple. It has a UI file and the code, and always the same function that is called MASTG test. So this way, we can always, if you open the website and you go to one of these demos, you can copy, paste to the clone repo of the app, and it must work. So we are going to do right now, so you believe me. So this is, let's use this one here. Oh, I'm starting with, if you just clone the repo, this is what you get. This is the function. You can make it a bit bigger. If we run this, you see this is extremely simple. If you click the start button, it's going to run exactly this function. And it's going to return some text so you can read something and see that something's going on, right? But that's it. Very simple. Okay. Now we go to the website. We go to a demo. Sorry for the scrolling. And we can get the original code from here. Copy to clipboard. Select all, paste, save, and run. So this is tested continuously by humans so that it works, but also in the GitHub Actions. For iOS, not yet in the GitHub Actions, but for Android, we are already building the APKs in the pipelines. And also in the future, we're going to run against virtual devices, so to ensure that this is continuously working. So let's go back to the presentation. So that's how you run demos. And let's go into the demos. So this is the first one. We just saw it. This is about an RSA private key that is hard-coded. So let's take a look here. This is the demo. And I'm going to actually open the test first so you can see what's in the test. And then the demo is like, it's like an instance of the test. So in here we can see typically the apps would use the security framework with specifically this function, or Common Crypto with this function, or CryptoKit. So there are many possibilities. Then we have steps. This one is very simple. Why is that simple? Because we contain all the information. It is called a technique somewhere else. So you can learn about doing this stuff with Radare. We don't have to explain again and again in every test. And then this, after doing this, you should see all the instances where this thing is happening. And then the test is going to fail if you can find these calls to these cryptographic functions that are receiving a hard-coded key. So let's take a look at the demo. In the demo, we have a sample code. I'm not going to show you. I'm going to keep to the disassembly because that's what we are going to use. I'm going to show you in the end. But you see there's a very long code here. So let me get to the text again before, at the end. Very big function, right? So you will unzip the app, you will open it, you will get the binary, and then you can use Radare with the I version because we are, option, because we are going to load this script. This script is specifically prepared to do this. In the future, we might move it to Python to make it more dynamic and not have to hardcode all these addresses and so on. But we're starting with this very simple. So we're going to first search for the uses of specifically what was mentioned in the test. This is a demo that is specifically for this. We have another demo for Common Crypto, and we might have a demo for Common Crypto but with another tool, so we can have all these combinations, so you can also learn to do the same thing with different tools. And then we search for the cross-references, and then we're gonna just print the function to a file, and we also could find the key, the hard-coded key, so we are gonna also store that. And then we have a script that you can run, and then it will get you all the output. What is the output? It's also here. You can see this is the output. We could find a use of that function. We can search for the cross-reference. Where is this function being used? In this other function. And then we have the full code above. And then it's telling you, I'm going to hide this intentionally, the test fails because in the end we can find the key, which is here, and we can see it with radar at the end. So let's, no, now I'm going to show you. It's gone? Oh no, it's working. So I said this is all in GitHub. Every demo is contained in a folder, so you can just clone the repo, go to the demo, open the folder, and in this case you can find the app binary. So we extracted that already from the IPA, so you just have the main binary of the app to make things easier. And then you have the original code, which is here, and the rest, the test script and everything. So, and also the cool thing is that if you just open here in integrated terminal, you should be able always to run the scripts, and that's going to override these files in this case. That's why you don't see anything meaningful here. The cool thing with this is then you can take the R2 script that is, what is it gone? Here, sorry. Here, and you can change it and play with it and try to get other inputs and so on. You can try with another binary. If you replace this binary with another one, you can try to do the same and play with this. So going back to the code, this is the disassembled code. So what we can do is, I'm going to show it to you here. So this is the function. And let me just check again here. We were looking for this, right? So we go to the function. And then we see that it's been used here. But we cannot really see where the key is coming from. It has to be there somewhere, but we cannot see it that easily. So in this case, you could spend some time analyzing all this disassembly until you find the key. Or maybe we can use AI and give this and then get something out. So that's also here. Decompiled, I use the O1 review model, and this is what we get. You can see the key bytes shortened for brevity, and then you can see how specifically all this code is being used. I'm going to show you now so you can see what was the original code and what is the new code, the AI decompiled code. So the original code, we have it here, and then I'm going to open the other one here to the side. I'm going to hide this, I'm going to hide that, and I'm going to collapse this, and I'm going to collapse this. So you can see more or less, the function doesn't have the same name, but that doesn't matter. So you can see that it's basically the same, more or less, right? So good enough for me to understand what's going on. It even translates all these things. Interesting. It's breaking. And it explains you without telling it to explain, like, look, step 4, step 5, and so on. Really nice. Let's take a look at a second one. So this is this one. This time, common crypto and insecure encryption algorithms. So the second one is this test. In this case, for insecure encryption algorithms, we have to take a look at common crypto. and CryptoKit, and not the security framework in this case. That's explained over there. And there are several algorithms that we might be able to find there in both cases. And then we're going to run the same way with Radare and a similar script, and we'll get the observation and the evaluation, and we're going to see that it contains some of these algorithms. So this is the demo. Again, the disassembly. This is, I think it was a bit shorter, but still, see, we can already see the ccrypt function here. And then we can guess that here probably we can find if this is encrypting or decrypting, but we don't know. So let's continue. And let's see if we run all these commands. They are very similar to the ones before. Let's search for uses. Let's cross-reference, find cross-references. Let's go there. Let's get that code and so on. And this is what we get, again, as that piece of code, again, but we still don't know what's going on. So we need to keep researching. So we do that, and we find out, okay, if we go to the headers of the function, we can find what are the arguments and what they mean. So for instance, we have first operation, it's encrypt or decrypt. Then we have algorithm. We should be able to find the algorithm over there. Then the key length, data in, data out, blah, blah, blah. Okay, so we do that. Then we also find what is the meaning, what are the numbers that we can expect there. 0, 1, like AES is 0, DES is 1, triple DES is 2, and so on. Same with the algorithms and the mode. Encrypt is 0, decrypt is 1. So then we go back, and then we try to comment these things. So you see, okay, it's 0, so it's encrypting. It's 2, so it's triple DES, and so on. And then we do all this work, and in the end we can say, okay, so this is using triple DES, so this is vulnerable. Good. Let's use AI instead. So we did all this work, but actually, you know, if we would have used AI, we would have seen this thing here. We even see the key, we see the encryption, the text that is going to be encrypted. And look at this. You can already see that it's encrypting with triple DES, some padding, and you can see everything in there nicely. We're going to do exactly the same, so you see the before and after. And that was demo 18. Which is this one, and then we're gonna open here the original code, which is this, and here we're gonna open the reverse code. Yeah, so original code, reverse code, and there you go. If you see, I'm gonna scroll here so you can see more of the operation. So again, it's basically the same or good enough that you can understand what's going on in there and directly see all these things, which is, in this case, is exactly the same in that area of code. So it's really, really nice. So it's really good that Pancake did the talk before, because he explained all what can go wrong and how to make it better, so I don't have to. But yeah. I did it for several demos, so not every demo has the AI reversed code for now. We will add that in the future. But it will depend on the situation, as Pancake was explaining. And for instance, I think this one or the other one, it took me just one try, and in other ones, 2, 3 tries. It depends. But I use a very simple prompt in this case. And it worked pretty nicely, but I think because of the model, because this model can think, so it took more time to go through that. All right, and I think we still have a bit of time, right? One more demo. The last demo, which is about storage, again on iOS. The apps can try to exclude something from a backup, and this can be a good thing if it really happens. But if you read the guide, we tell you that actually maybe it doesn't happen, because even if you would expect it's excluded from backup, it would exclude something from the backup, but it doesn't. So Apple writes that in the documentation, like, yeah, you can use this function, but actually it's like it does nothing, but you can use it. You intend to exclude it, which is funny. So that one is here. So here is where we are explaining that. This is why this is so valuable. You don't have to go and find this in the Apple documents because we do that for you. And hopefully when you contribute, you will do that for other people. But here you can find all that information. And then we're gonna, again, do exactly the same in the demo, follow the same steps. And we end up with, you see again, a very long code. So this time I'm gonna just go and show you the decompiled version. Basically, it's not working. You can see that the file is created here. It gets an API key and then writes the API key in the file, and then it marks that file as is excluded from backup. So then we explain what you actually should do is probably encrypt that file. If it's very important, just prefer to encrypt it and not rely on this flag in the end. So this is again all the code and the results. You can see that we can find that string, then we search for where the string is used, so we can see in the disassembly this as well, not just using AI. You should still try to learn the reverse engineering, not just rely on AI, please. But yeah, the combination of you being able to reverse engineer and having AI, of course, is very powerful. So, but please keep learning and using Radares. So yeah, this is it for this demo. You can find Frida demos, of course. We have man-in-the-middle proxy for when you have some network stuff going on. All the things I presented with all those colors, you will find all the weaknesses, all the demos, and this is growing now with time. This is also, the demos are very new. Before we had like, the MASTG is a book. It's like, was these phone books. It's really thick if you print it. So you don't want to print it probably. That's why we build the website, so you can search for everything in the website and play with it and clone it with GitHub and so on. So please do that, and I hope you learn a lot. If you want to contribute, it doesn't matter the level. If you're a beginner, you're going to learn. If you're a professional, please contribute as well, because we need a lot of help to keep with this. And you can just, if you want to see a typo, you can start with that. Just edit, click, fix it, send it. That's something already. So we hope we can hook you with that. And yeah, again, this is me, and go to the website, contact me if you have questions or you want to contribute especially. So yeah, thank you very much. Any questions?
Questions. One question, one book of Radare, free of charge.
Are you guys using R2 as well?
Yes.
That question doesn't count for the. Come on, that's bullshit. Come on.
Yeah, if you go to the website, you go to the MASTG, and you see kind of all the components that we have, techniques, demos, tools, and for instance here, you see we have R2 Frida there. So we treat everything as a component, like a function, tools, techniques, and that's cross-reference across the guide, so you can always find all this stuff.
Let me reply, Novella. Read the fucking manual.
Read the fucking MASTG, yeah. Thank you. More questions? Well, I'll be around, so approach me anytime.
Big applause, big applause.
Thank you.